continue next topic. The next topic is an empty set. What is an empty set? Empty set means, the word empty means there is nothing in it. The same is the concept with the empty set. A set which does not have any element in it is known as an empty set. So first we'll write the definition, then we'll move on to the examples. So write the heading as the empty set. Write the definition. A set which does not contain any element in it is called an empty set or a null set or a void set. A null set or an empty set is denoted using the symbol phi. Example, first one, set X such that X is an even prime number greater than 2. Second example, set X such that X is a student studying in both class 10 and 11. When we consider both the sets, look, X is an even prime number greater than 2. We always know that the only even prime number is 2. There is no other prime number which is greater than 2. So this is a null set. And the second one, X is a student studying in both class 10 and 11. So it is not possible for a student to sit both in class 10 and in 11. So this is also a null set. Now next heading, finite and infinite sets. The word finite means countable or a definite number of elements will be there. So a set which contains a countable number of elements or a finite number of elements is known as a finite set, and all other sets which contains infinitely many number of elements is known as infinite. A set which is empty or consists of a definite number of elements is called a finite set. Otherwise, the set is called infinite. Example for finite set, number of days of a week. Example for infinite set, set of natural numbers. Next heading is equal sets. When can we say that two sets are equal? When we consider two sets or when we compare two sets, every element of the first set should be there in the second set as well. That means every element in the first set should be an element of the second set as well. Then we can say that the two sets are equal. So write the definition. Two sets capital A and B are said to be equal if they have exactly the same elements and we denote it as A equal to B. Full stop. Otherwise, the sets are said to be unequal and we write it as A not equal to B. An example, capital A is equal to set 1, 2, 3. B is equal to set 1, 2, 3, 1, 3. Here, number of elements may be different. But look, 1, 2, 3 is there in set A, 1, 2, 3 is also there in set B, and the same elements are also getting repeated. So this can be represented as 1, 2, 3 itself. Here 1 and 3 is getting repeated. It's not mandatory that the repeated elements are again written. So we can say that set A equal to set B. Now we'll move on to some examples. Example 6 from the textbook. State which of the following sets are finite or infinite. First one, set X such that X belongs to the set of natural numbers capital N and X minus 1 into X minus 2 equal to 0. X minus 1 into X minus 2 equal to 0 means X is equal to 1 and X is equal to 2. Therefore, we can write this set as set 1, 2. This is a finite set. Next one, x such that x belongs to n and x square is equal to 4. X belongs to the set of natural numbers. X square is equal to 4 means x is equal to 2. Why don't we consider minus 2? Because here it is clearly given x belongs to the set of natural numbers. Negative 2 means it will belong to the set of integers and the condition is not satisfied. So simply x is equal to 2. Therefore, for question number 2, the set is set 2 and it is a finite set. Third one, x such that x belongs to n and 2x minus 1 equal to 0. 2x minus 1 equal to 0 means 2x is equal to 1, x is equal to 1 by 2. Will this number be a part of this set? No, because it is given that x is a natural number. 1 by 2 is not a natural number. Therefore, the third one, the answer is null set, which is again a finite set. Number 4. Set x such that x belongs to n, x is a prime number. You have to list down all the set of all prime numbers. It will start from 2, 3, 5, etc. and it is not countable. It is an infinite set. And the fifth one, set x such that x belongs to the set of natural numbers and x is an odd number. That means it is set 1, 3, 5, etc. till infinity. That is again an infinite set. Now we'll move on to exercise 1.2. Which of the following are examples of a null set? First one, the set of odd natural numbers divisible by 2. We all know that no odd number can be divided by 2. Therefore, that set is a null set. Set of even prime numbers. Set of even prime numbers, 2 is an element of that set. So, it is not a null set. Not a null set. Third one, set x such that x is a natural number, x less than 5 and x greater than 7. No number is both less than 5 and is greater than 7. So, that is also a null set. Then, number 4, y such that y is a point common to any two parallel lines. Parallel lines means no point of intersection. That means there is no point common for two lines. So, it is also again a null set. Now, we'll move on to question number 2. Which of the following sets are finite or infinite? Which of the following sets are finite or infinite? First one, the set of months of a year. We all know that there are only 12 months and hence it is finite. Second one, 1, 2, 3, etc. till infinity. The set of natural numbers, infinite. Third one, 1, 2, 3, etc. till 99, 100. It is countable and definite. Therefore, we know that it is finite. Number 4, the set of positive integers greater than 100. Positive integers greater than 100 means 101 till infinity. That is infinite. Number 5, the set of prime numbers less than 99. The set of prime numbers less than 99, it is countable, hence it is finite. Then, moving on to question number 3. State whether, again, each of the following sets are finite or infinite. The set of lines which are parallel to the x-axis. The set of lines which are parallel to x-axis means we can draw infinitely many lines which are parallel to x-axis. Therefore, it is infinite. Next, the set of letters in the English alphabet. It's 26, hence it is finite. The set of numbers which are multiples of 5. You have infinitely many numbers which are multiples of 5, hence it is infinite. Next, the set of animals living on earth. The set of animals living on earth. Is that finite or infinite? The set of animal living on earth is finite. There is a list of animals which is living on earth. Then the set of circles passing through the origin. You can draw circles of any radius, no matter which is the radius, so it is infinite. Moving on to question number 4. In the following, state whether A equal to B or not. Look at the two sets, compare the two sets, and we have to write whether A equal to B or A not equal to B. The first set, A, B, C, B, B, C, B, A, all the elements are same, but written in a different order. That is not a problem. So we can write the first one, A is equal to B. Then second one, A is equal to 4, 8, 12, 16. B is equal to 8, 4, 16 and 18. There is an additional element 18 here and a missing element 12 there. Therefore, in the second one, set A is not equal to set B. Number 3, A is equal to 2, 4, 6, 8, 10. B is equal to x is a positive even integer and x less than or equal to 10. All these elements satisfies that condition, and we can write capital A is equal to capital B. Number 4, set x such that x is a multiple of 10. Here B is equal to 10, 15, 20, 25. Here it is clearly given x is a multiple of 10. Here multiples of 5 are also included. Hence we cannot say that both the sets are equal. Hence A is not equal to B. Now moving on to the fifth question. Both questions are related to the topic equal sets. So please complete question number 5 and question number 6 as homework. Hope you all have completed the previous one question from exercise 1.1 as homework completed, and keep it ready in your notebook when you come back to school. So question number 5 and question number 6 are homework questions. Now we will move on to the next topic, subsets. What is a subset? Subset means if you have a basic set, let it be the set of natural numbers, and if I am writing another set A which is equal to set 1, 2, 3, 4 and 5. We already have the set of natural numbers, set 1, 2, 3 etc. till infinity. I am writing another set A which is set 1, 2, 3, 4 and 5. All the elements of set A is an element of the set of natural numbers. Hence we can say that A is a subset of set N, and it can be denoted as A is a subset of the set of natural numbers. This symbol is the symbol of subset of. Is read as is subset of. So A is a part of this set of natural numbers. Hence A can be a subset of the set of natural numbers, and the basic set N is called as the superset of A. Hope that topic is clear. Now we'll write the definition of subsets. A set capital A is said to be a subset of capital B if every element of A is also an element of B. In other words, A is a subset of B if A belongs to A and A belongs to B. The small letter A is an element of A and an element of B. The symbol denotes is a subset of. Full stop. Next line. If capital A is not a subset of set B, then we denote it as A not a subset of B. Write as a note. Every set is a subset of itself. Since empty set phi has no elements in it, phi is also a subset of every set. Write an example for a subset. The set of rational numbers is a subset of the set of real numbers, or the set of natural numbers is a subset of the set of integers. All these are examples of subsets. What is a proper subset? Proper subset means if we have two sets and if A is a subset of B, then if the set A is not equal to set B, then we can say that A is a proper subset of set B. Proper subset. If A is a subset of B and if A is not equal to B, then A is a proper subset of B. Example, A is equal to set 1, 2, 3. B is equal to set 1, 2, 3, 4 and 5. Here A is a subset of B and A is not equal to B. Hence we can say that A is a proper subset of B. Again write as a note. If any set has only one element in it, we call it as a singleton set. Example, the set of all even prime numbers. Now the next topic is intervals as the subsets of real numbers. Write the heading as intervals as the subset of real numbers. What do you mean by an interval? The word meaning is interval means a break or a period of time from your what will be your school break. From lunch break is from 12:15 to 1. That means it over the clock 12:15 to 1 is your lunch break. That is your interval. Same is the concept in the set of real numbers. Interval means it is a set of numbers between two numbers. So if we consider two numbers A and B, where A less than X less than B, then on the number line, let this be 0, let this be A and let this be B. This all the set of all numbers that lies between A and B belongs to this interval A less than X less than B. Here we are going to learn about 4 different types of intervals. That is mainly open interval and closed interval. Again left hand side open interval, right hand side open interval, and kind of similar kind of intervals we are going to learn. First thing, we will write the introduction. So please write, let A comma B, A and B belong to the set of real numbers, and A is less than B. Then the set of real numbers that lies between A and B, which is denoted as A less than X less than B, is known as an open interval and is denoted by A comma B. You have to be very careful with the brackets. It is open brackets, simple brackets. It is A comma B. All the points between A and B belong to the open interval AB. All the points between A and B belong to the open interval AB. And A and B themselves does not belong to this interval. And A and B themselves does not belong to this interval. So to explain it more clearly, if we draw a number line like this, and let this be -5 and let this be +3. I am writing the open interval -5 to 3. What does this mean? This means -5 less than X less than 3. We have to be very clear about the inequalities. -5 less than X less than 3. Open interval -5, 3 means -5 and 3 themselves does not belong to this interval. All the real numbers which lies between -5 and 3, all the real numbers which lies between -5 and 3 will be an element of this interval or belong to this interval. Such type of intervals in which the end points does not include in the interval is known as an open interval. Now we'll learn what is a closed interval. The interval which contains the end points is called closed interval and is denoted by a comma b or a less than or equal to x less than or equal to b. Look at the inequality symbol. Previously it was simply less than, then a and b was not part of that interval. Here it is less than or equal to. Hence the end points also belong to the interval. The same example we will write -5 to 3 or -5 less than or equal to x less than or equal to 3. Closed a comma b. What does this interval represent? Closed bracket means that endpoint will be included in the interval, and open brackets means that endpoint will not be included in the interval. So how do we write it in inequality form? It can be represented as a less than or equal to, here it is closed, so it is less than or equal to x less than b. Is b included in the interval? No, but a is included in the interval. Then next one, a comma b. What is it? How can we write it in inequality form? A is not included as it is open. So a less than x less than or equal to b. So please write the first one. Closed brackets a comma b open brackets implies a less than or equal to x less than b is an open interval. This is an open interval from a to b, including a but excluding b. Including a but excluding b. Then the second one, a comma b closed brackets. Here it is the simple brackets, which can be denoted as a less than x less than or equal to b. This is an open interval from a to b, including b but excluding a. All these four types of intervals can be represented on a number line. Now listen to how to represent all the four intervals on a number line. Which are the four intervals what we have learned? First is open interval, second one is closed interval, then a comma b, and these are the four types of intervals which we have learned. Let this be the number line. Open it, let this be the value a and let this be the value b. Open interval is always using a plain circle. Plain circle on a number line means that particular point is not included in the interval. So here a and b, the end points are not included in the interval as it is an open interval. So you have to draw two plain circles. When you see two plain circles at the end points, you have to understand that it is an open interval and the end points are not included in the interval. So how can we represent this one? This is A, this is B. Closed means it is represented using a shaded circle. So you have to shade the circle like this. If you see a shaded circle, then you have to understand that the end points or the point or the number where the circle is shaded is included in the interval. This represents closed interval. So how can we represent this one? A and B. This is the number line. A and B. A is closed and B is open. A is closed and B is open. A is closed means B is open. You can leave it as a plain circle. A is closed means the point A should be shaded, which means A is included in the interval. And the last one, A and B, here A is open and B is closed. That means B is included, A is not included. So this is left as a plain circle and this is a shaded circle. So now all of you please write down all the 4 different types of intervals and how to represent it on a number line. You have to draw it in your notebook. We'll write some examples of intervals. First, write as a note, an interval may contain infinitely many points in it. Example of an interval, -5 less than x less than 7. How can we represent this in interval form? -5 to 7, both open because look at the inequalities. -5 and 7 is not included. Another example, -3 less than or equal to x less than 1. How can we write this? -3 is included but 1 is not included. So how will we write? -3 closed brackets -3, 1 is not included. So it should be left as simple brackets. Now, when we consider an interval A to B, what will be the length of an interval? The length of an interval means here A is less than B. So B will be always greater than A. Hence the length of an interval means it is the difference between A and B. So always we can write B minus A is the length of any given interval AB. So write as a note, the number B minus A is called the length of any interval AB. Now we'll move on to the next topic, power set. What is a power set? Have you ever heard about a power set? Power set means, let us come back to the topic of subsets because power set is involved with subsets. If we have A is equal to set 1, 2, 3, how can we write the subsets of A? The set itself is a subset. Therefore, subsets are set 1, 2, 3. Then null set is a subset of every set. Then we have set 1 is a subset. Set 2 can be a subset of this. Set 3 is a subset of this set. Then combinations of 2. Set 1, 2. Set 1, 3. Set 2, 3. All these are subsets of this given set. That is, count how many sets are there. 1, 2, 3, 4, 5, 6, 7 and 8. So 8 subsets are there for this particular set A. Now coming to the concept of a power set, when we consider the set of all subsets of a given set, that particular set is known as power set of a given set. If we consider all these sets as another set, let it be set B. B is the set of all subsets of a given set A. Then B is called the power set of A. Hope it is clear. A set is given. We can list down its subsets, and if we consider all those subsets as one single set, then that is known as the power set of the given set A. The collection of all subsets of a given set A is called the power set of A, and it is denoted as capital P of A. In a power set, every element is a set. Look at this power set. Each element, look at each element, all the elements are different sets. Therefore, in a power set, every element is a set. Write this example. Example, A is equal to set 1, 2, 3 and write power set of A as set of set 1, 2, 3, null set, set 1, set 2, set 3, set 1, 2, set 1, 3 and set 2, 3. Now we'll move on to the concept of universal set. What is an universal set? What does the word universal means? Universal means the most biggest one. So when we consider different sets, let it be the set of natural numbers, the set of real numbers, or the set of rational numbers, or the set of integers, which can be a universal set of all these. We are considering the set of natural numbers, the set of rational numbers, the set of integers, etc. Now, which can be a universal set of all these? Can it be the set of real numbers? Set of real numbers means all these sets belongs to the set of real numbers, or all these sets, natural numbers is a subset of the real number, rational numbers is a subset of the set of real numbers, integers is a subset of the set of real numbers. So, a biggest set or a basic set is known as an universal set in which there are many subsets for it. So, write the definition. Any basic set can be a universal set. Example, for the set of all integers, the universal set can be the set of rational numbers or the set of real numbers. The universal set is represented by the letter capital U.